First off, I would like to find, this is what the task is going to be. I have y equals cosine inverse of x, and I'd like to find dy dx of that. Or I could write it this way, the derivative of the cosine inverse of x. Okay? That's going to be the task. With that in mind, I'm going to write this in a different form. We're going to start this way. Y equals cosine x. Now remember, this is a different y than this one. Okay? This is my function. This is my inverse function. So just so you notice, those two are different. Now, pardon? This is a proof. Yes. And so I'm going to find this one's inverse, which is going to be then written this way. X equals cosine y, changing the x's and y's around. And I'll give you a little picture here. And that function goes this way. Okay? That is, oopsie, yeah, that's this function right here. And it's also written this way. Y equals the cosine inverse of x. See, now I'm here again. See that? I'm over here. I started with this function. And I'd like to give you domain and range. So we figure that out, and that'll be helpful in a few minutes. The domain here is I'm going to run from here to here. So it's going to be 1 is less than or equal to x minus less than or equal to 1. Question on that? Range. Negative pi halves less than or equal to y less than or equal to pi halves. Okay? I'm going to do something else here in a minute. That if, yes?
Why is it negative pi halves?
Because I have a mistake. 0 to pi. Thank you, because I needed it in just a moment. And I would have caught it then, but not before. See, I run from here to here. This height is pi. Okay? Now, what would be the value of the sine of y in what's defined up here? In here. And in this case, this is going to be positive. Okay? If I just look at the sine, I'm not looking at the inverse of a function, we call it y, and this is the sine curve. And now all of a sudden this just happens to be y, because of the way I've done this. And you notice that from here to here, right in here, that's all positive. Okay? So this is going to be positive. Any question about that? Just some stuff that will be helpful in a moment. Okay, now, we've got this, and this. I'm going to take this right now and do implicit differentiation. This here is like this. You see, these two are the same thing, just a different way to write it. And so I'm going to take that for this, and I'm going to make that x equals cosine y. The derivative of this is 1 explicitly equals what?
Sine 1.
Got it. Very good, Grant. Y dy dx. You with me on that? Okay. So dy dx. Now notice something else. How these two vary. This y over here is this business over on this side here. See it? This y, how I wrote it out. See that y is missing in this one? Okay, and now I'm writing this way. I could have changed that a little bit. Okay, this is equal to 1 over negative sine of y. Okay? Now, I don't really want sine of y. I'd really like an x there. Okay? So, this is the way I do that. There's a little more doodling on the side here. I know that the sine of y squared, like that, plus the cosine squared of y, that's going to be equal to 1. Okay? We know that kind of stuff. Now I'm going to take this here. This is going to be the sine squared of y equals 1 minus the cosine squared of y. take the square root of both sides, like this, this becomes plus and minus. So this is the sine of y equals plus or minus the square root of 1 minus cosine squared of y. Questions on that? Okay, at this point, I'm going to throw this minus away because I've said it's always positive. See that? I'm going to throw it away. I may do that. Okay, so it's just going to be the plus amount. Okay, so this here quantity here is actually equal to 1, and now this minus is still here, but this whole quantity is positive, so that's going to be the square root of 1 minus cosine squared y. But up here, I said the cosine of y is x. So I find out this is equal to 1 over 1 times the square root of 1 minus x squared. Okay?
So for our proof, do we need both, all that? Or what do we need?
Pretty well. Some of you would chop it down a little bit. Yes?
Could you, from the sine squared y plus cosine squared y,
Here?
can you just kind of give a little summary of what you're doing?
From here and here down?
Yeah, why are you doing what?
Okay. You know that way back we said sine squared x plus cosine squared x equals what? Pythagorean relation. But I'm just saying we're going to have a y here instead of x. Could be for any x. It's always true. And so I just do it this way. Okay? And now I move this to the other side of the equation and just let the sign here alone. So it becomes 1 minus this. Okay? And then I take the square root of both sides and I have this. And then it's equal to a plus or a minus. But up here already, I said this quantity, notice that there's a y here. That was up here, because it's in here. That has to be a positive value. Okay? And now I know that this quantity right here is an x. See, that's how you get this down there. Okay? Yes?
The domain and range of what function is that?
Okay, this is the range and domain of this function right here, which is this function right here, which is f inverse of x if this is f of x. Okay? Now, something else. Just take a little peek here at something, and we'll do it again later. And that's this. When I took the derivative of this, see, how do I want to say this? I'm going to take this here, right here. Now, watch what happens here. Just a moment. This finger here is with a purpose too. This is my original function. What's the derivative of this?
Negative sine x.
Oopsie, negative sine x. And notice that this, its inverse, is the reciprocal of it. See this? It's on the top. Here it becomes the bottom. And the other shift you make is you change this x to a y. That's the very last thing in this section. 3.9. I won't get at it today, but I was just going to show you that. You take the derivative of this, and this is going to be its reciprocal. Changing the x and y's around. Okay? See how that works. I will also prove that very quickly, I think, on Monday. Okay? So that's this one. Now, let's do something else again before I do the next one. Will you go to the back of the book? And the back cover. And I want to show you that we are basically finished with derivative stuff in terms of finding functions. Okay? General formulas. Notice that all of them have been covered. Okay? The trig ones. I specifically did sine, cosine, and tangent, but the other ones we talked about. And I try to stay away from it because that's a little bit of an overload. Okay? Now look at the inverses. You've got the sine inverse, you've got the cosine inverse. We don't have the tangent yet. We're going to do the tangent one in just a minute. And then the other three are not that hard to get from the other ones. although we won't deal with them much. Yes,
For a test, are we going to have to know how to get these inverses?
absolutely. Yeah. Okay, and now notice the exponents and the logarithms. You know all those too. The only ones we don't have is hyperbolics. And that's later on in the book. Okay, and we won't deal with those. Okay, so we've got all of them. We just have to do the tangent one yet. Okay, so let's do that one, and it goes pretty fast. So here we go with the tangent. We'll start with the function y equals the tangent of x, and then we'll take a look at it. Oh, we'll call this f of x. That's nicer. And its graph looks like this. This way. And then there's another one that comes here, etc. Okay? And we want to look at its inverse. So we're going to change x's and y's around. So then we're going to have x equals the tangent of y. And its graph is going to look like this. It's going to run this way, come this way, and it keeps going this way forever. And this way too. Okay? And I'm going to write something else here in a moment. What is the domain of this thing? All x. What's the range? Negative pi halves.
2 pi halves.
Is less than or equal to x is less than or equal to pi halves. Okay? That's from here to here.
Yeah, wouldn't that be a y?
Oh, absolutely.
Chapter here, bear.
That's a y. Okay? Now, another thing here. This becomes then y equals, and now this y is a reciprocal of this one.
Wouldn't
Like,
it be, I have a question, for the range, wouldn't it be just less than, because it doesn't, because aren't pi halves and neg pi halves asymptotes?
No, that's a point on the graph. You can do that.
Well, yeah, but one, for the range,
It never goes above those lines.
yeah, it doesn't go above those lines, so it wouldn't be equal to it. Right?
Oh, I see what you're saying, there's no.
It's not
she
like,
isn't like,
it should be just less.
and rightly so. Thank you. Yes. I should not have had the equal signs on there. Okay? Because those are asymptotes, is what she was saying. She made it so clear that I wasn't following. Okay?
Is that the same for the other ones?
No, it's not for the other ones. This one is this one. Pi halves negative is less than y is less than pi over 2. Okay, now, we're going to start off with this one, where we can handle it. And what we're trying to do is find this one's derivative. Derivative of this. And so, that becomes 1 equals
Secant squared
secant squared
y
y
by dx.
dy dx. Okay? Now look at this. dy dx equals 1 over the secant squared of y. Now before I go, I'm just about finished on this one. So watch something else. I said the derivative of this and the derivative of this are reciprocals of each other. See that? See? Isn't that cool? Now, it doesn't come into your reading. You're not going to read into that, but I wanted to show that so that when you do some problems later, you kind of see how that works. Okay? Now, here, I know that the secant squared a equals 1 minus a plus the tangent squared a from the blue sheet. Or you know it in your head. Okay? You know that. Okay, but now I don't have a here, I have y. So this turns into 1 over 1 plus the tangent squared a. Like that. Oh, this is supposed to be a y. See that? Y. Questions? We're just about finished. I know that we have this also in this relationship. So this gives me 1 over 1 plus x squared. We're done.
Because y, obviously,
Pardon?
y is almost x squared.
Because x is equal to tangent. Therefore, you square each element by slope.
Okay.
Okay?
That's myth.
Questions on that? Okay, now, that went pretty quick. Then I'd like to do one example, and then we're going to get the test back and do a few things there. Here's my function. Some of the problems that I've assigned should go pretty fast. And we have this plus 2 equals squared like this. And in this case, I'm going to define my domain to x is greater than or equal to minus 2. That's to keep this positive at this point, okay? And a point on here, let's see, that would be if x equals 4,
36.
y equals 36. So in this case, I have 4, 36 is my point. Now I would like to know what f inverse x dx of that is. What is the derivative of the inverse of this at this point? Here's my function, here's a point. I would like to know what the inverse derivative is at this point.
1.
And so that's going to, okay, we'll just do this here on the side. We have this here. And what's the derivative of this?
1.
Now this is a prime like this, it's not like this here.
2x.
That's going to be equal to 2 times,
X plus 2.
do the first times 1, right?
So 2.
So this is going to be 2x plus 2,
4.
4. So this one's derivative is going to be 1 over 2. Now, sometimes if we're going to use this notation up here, it's going to be 2y. Or you can do it this way, 2x plus 4, and we're looking at the point 36 comma 4. Because we're taking the reciprocal.
Yeah.
Okay? Or you can put this y as y here and use this one.
Well, that's as an ask, you're gonna put y in there.
Yes, you can do it either way. And you'll see it in the book in terms of y sub 0, in terms of what you have here. Okay? And so this turns into 1 over
76.
76.
Good job there,
What are
Derek.
what were we figuring
Way to do that
out
mental
there?
math.
That's the only thing.
There.
Mr. Kramer, what were you
Yes?
what were you doing there? Like, I understand what you did, but like, what is it for?
You count the derivative and stuff going on.
All of a sudden, I am in trouble. I don't think that's right. Yes.
Weren't you supposed to take the inverse first and then the derivative, not the derivative,
I take the inverse first.
and then find the derivative of the inverse? Or did you do that?
Yes, but I was trying to do it the fast way.
Okay.
Okay? So what you're saying, let's do that a minute. And I think I need something different here. I was thinking I had to switch them, but I don't think I do. But we're going to try to find it out for sure.
So what
We're going to
doing
use this
is-
first. This is my function.
Okay.
And we're going to make this x equals y plus 2 squared for inverse. And so then I will take the square root of x equals y plus 2. Now remember this restriction up here that helps us a great deal. And so we have here y, which is the inverse one, like this, is equal to 2 minus the square root of x. And now,
Wouldn't it be square root of x minus 2? Because you'd have a negative y.
Yeah,
It's square root of
square root
2.
of x minus 2.
Yeah.
yes, okay? And now this one, its derivative, dy dx, is equal to
1/2 x. And then
1 over 2 square root of x, right?
yeah.
Minus 2.
Why is it 2 square root of?
Pardon?
You explain that?
This here, that's x to the 1/2.
Oh,
Yeah.
and then it's
So
the negative 1/2, so you put on the
I
bottom.
isn't the minus 2
Oh.
0. It's a constant.
You happy now?
What are you?
But when
Or not.
it's the,
No. Why did
No.
you change it? Why did you change it to
Oh,
minus?
it's still,
But
oh yes, it's still minus. Okay, Greg, I didn't follow you.
Well, isn't minus 2 a constant?
so there isn't.
It's fiction.
How come it's not 0?
Okay, you're asking the derivative of this yet? Is that where the
No.
question
No.
is?
Isn't the derivative of negative 2 0? Is what they're asking.
Okay, just a second. So this gives me 1 over 2.
No,
We
Okay.
have that part.
We got that.
It
Okay,
wouldn't be minus 2 though, because
Nice.
that's a constant. Well, it ain't either.
okay, now,
It's a constant.
I'm happy at this point. Okay, now, if I put my x in here, this new one, that's going to give me 1 over 12. Okay, and so up here, I should have used this here, x over here, which would be 8 plus 4, giving me 12.
Whoa.
So, what was that?
So we better check on that one. There are a few problems, and make certain, like, these are 39, 40, and 41. Yes?
Why don't you do the 36 if you don't need that? Or,
Um,
yeah, it's not relevant to
The only thing there is I used it down here when I switched it. And this didn't go quite the way I wanted it yet. Look it over, and I will talk about it more on Monday. Okay? Yes?
Which one do you want us to use? The one that you just circled or the one that's below?
Whichever one you like.
Whichever one you like. I prefer this other one up here. It's quicker.
So you prefer the derivative than the inverse?
Take the derivative of the function. Take the derivative of the function. And then you're going to find the derivative of the inverse. And just take the reciprocal. And I will do a little bit more work with proving that next time. The example is on page 208. 208. The example 5. Okay? Okay. The next thing for today, we're finished with that.